Why do we feed our pigs and chickens non-GMO feed? The answer may not be what you expect. Hi folks, I'm Neil of Anchor Ranch Farm, here on the beautiful banks of the beautiful Thomas Creek in beautiful Scio, Oregon, where just this past weekend our town had the annual Lamb and Wool Fair, the oldest fair of its kind in the state of Oregon, or so I'm told. And just down the road from us was the Northwestern Sheepdog Trials, which, if you have a 2-year-old or you like dogs, is a great place to go. So, to the question, why do we feed non-GMO? The answer is math. Now, this argument is explained much more rigorously in a New York University School of Engineering working paper co-authored by Nassim Nicholas Taleb, entitled "The Precautionary Principle: An Application to Genetically Modified Organisms," or something like that. A lot of the time when people use what they say is the precautionary principle to make an argument, they don't understand the precautionary principle and they don't understand probability statistics. But in this case, the precautionary principle is just that if you could take an action and there is a possibility that the permutations of that action are unlimited, meaning you cannot stop it once you start, and there is any positive, real risk that action could result in systemic collapse and failure, you should not do that. So, a sci-fi example of this is the gray goo phenomenon. A futuristic scientist or someone in Silicon Valley today makes a self-replicating tiny little robot that can make copies of itself from stuff that it finds, releases that robot into the wild, and neglects to put in a way to turn it off. So the first robot makes a copy of itself, then those 2 robots make copies of themselves, then those 4 robots make copies of themselves, and in not too long, the entire solar system is made up of a gray goo of self-replicating autonomous little robots. Not a good ending. With genetically modified organisms, with a non-genetically modified organism, with a hybrid or something that's bred over time or something that you just find in the wild, what you're looking at is what's called a thin-tailed probability distribution. And what that means is, over probably millions of years, many solutions have evolved to address an environmental problem, or a series of environmental problems. And by environmental problem, I mean a problem that is exogenous to the organism itself, not Greenpeace environmentalism. So you have lots and lots and lots of potential solutions tested over millions and millions of years to whatever bevy of problems arise. And in a thin-tailed probability distribution like that, if one set of solutions fails and chops off a piece of that long, thin tail, well, you still have a lot of other solutions to work with in nature. So there's not really a chance of one catastrophe destroying everything. We have species get wiped out all the time, but and you have very similar species that can fill the same environmental niche, or you have new species that can evolve from existing species to fill the same environmental niche, or the environmental niche that a species was filling went away, which is why the species died, but it's not needed anymore for the health of the ecology. In an engineered solution, such as, which is what a genetically modified organism is, you have a fat tail probability distribution. So you have one solution or set of solutions applied in mass to probably a pretty small set of known environmental problems, simply because we haven't been around that long as human beings doing science. And science is good when you're responsible about it. So you have an engineered solution, top down, not evolved from the bottom up, where you've done experiments, but you haven't done millions and millions of iterations for millions and millions of years. So, what does the probability have to be that some environmental change or effect or mutation in the organism would result in catastrophic, systemic, complete destruction of that organism and potentially its environment? And the answer is the probability only has to be above 0. So, is the probability that a genetically modified organism that we create using genetic technology, not by breeding or selection, is the probability that that organism will someday encounter something that kills all of those organisms more than 0? Yes. Yes, it is. So, if you want to buy genetically modified tomatoes, that's fine. I'm partial to the argument that there is something good and pure and true about an heirloom tomato, and plus they taste a lot better. But if you want to buy genetically modified tomatoes, I suppose there are some people who say they can't live without tomatoes, but if the genetically modified tomatoes take over and something happens and all the tomatoes die, we'll probably survive. However, the global population of the Earth depends on a very, very, very few cereal crops for almost all of our caloric needs. Now, things like pasture-raised, grass-fed animals, animals that can forage for their own food, eating a varied diet that doesn't consist mostly of grains, but is balanced, that can all contribute to mitigating that potential problem. But as things stand right now, if the corn and the wheat and the rice that we grow in the world all died, pretty much everyone would starve to death. So if you have a genetically modified cereal crop and it is not rigorously quarantined, it can spread to neighboring fields, and it's been designed in a lab to outcompete non-GMO varieties in normal, foreseen environmental circumstances. That's important. So over time, you have genetically modified cereal crops that can propagate. And if you say, oh, we'll design them so they can't reproduce themselves, then you were too afraid of the T-Rex in Jurassic Park 1 to pay attention, because nature finds a way. That movie had horrible science, but that's just math. They have the potential to replicate themselves, potential to spread wherever those crops can be grown. They have the potential to force out other varieties, and they're an engineered top-down fat-tailed solution, so there is a probability greater than 0 that at some point they will encounter something that kills them all. That would be bad. And that is why we feed our animals non-GMO grains. We support farmers who grow non-GMO varieties, and we encourage you to do the same. We're certainly not opposed to scientific, engineered solutions to problems, but in this case, we can grow grain that is non-GMO. It's less profitable, but there is a limited upside profit potential and an unlimited downside everything dies potential. So that's a bad trade. This principle does not apply to a lot of other things that people think it applies to. It is not a reason to avoid scientific research. It is not a reason to avoid engineered solutions based on science. But it does apply in this case. So thanks for listening. Hope that's helpful. From the nice and cool in the sun pig shelter, mobile pig shelter, here at Anchor Ranch Farm. Thanks for watching, and peace be with you.